you talk to me last night?
No.
Nope.
He knows what's up. We talk to him.
No, not about Derek. But,
That one shirt made me think of this. The classic Beatles, Abbey Road.
yeah.
Have you ever heard of, it's called like car karaoke or something? It's
Yeah.
on the late night show, and they take in
Yeah,
artists.
it was Paul McCartney.
Yeah.
That was awesome.
It
I
was
couldn't
such
watch
a
all
cool one.
couldn't watch all 20 minutes of it, but I was very irritated that I had to miss some of it because it was really
It was
good.
great.
Yeah.
What's his childhood home?
Yeah. No, it was very good. It was
Not the
definitely
most comfortable placement of this
definitely
steel.
a good one. In fact,
Yeah.
it made me subscribe to what's the guy's name?
We'll see what we can do with the break.
Oh, we're good.
The host.
Just
Whatever.
get settled in.
What?
James
James Gordon. Yeah, it made me subscribe to his stuff because that was awesome. It was pretty good.
I can't imagine them getting the same
Car karaoke with.
Paul McCartney.
And, the phone call at the beginning is, help. No, I really need somebody. That's funny. All right, so are we casting?
I'll send that to you and we can do it at the break.
Let me know when you're ready.
Ready?
You ready? Okay, good.
Ooh, do you want to do any sort of intro about my presence here, or do I just pretend like nothing happened? Just start. So our vehicles.
Are you streaming?
Yeah, it's up. There you go.
Good morning, everyone. Welcome back. Happy Monday morning, and to another week of exciting learning about programming of varying degrees. So, as you can see, Derek has decided to join us here in Winston-Salem at my suggestion. And the reason that is because I believe we're having some difficulty on the simulcast. Not technically, but when somebody is 5 hours away geographically and they're talking to you and you've never met this person, it's difficult to understand how they're trying to express themselves. And we've talked about some other things based on some feedback Friday afternoon. And we're hoping that this will be more effective for both Richmond and Winston-Salem, every participant. Our goal is so that you all actually get this. It's not high school, remember. I mean, if we're going back to high school and it's kind of optional if you get this stuff, we might as well go home because this is a failure. So we're doing everything we can to make this as effective for you as possible. And remember, my motives are not completely altruistic. So, Derek is here. Now, Richmond, before you start an uproar and start talk of mutiny with Harper and Brendan there, he is coming back. He is going to be back in Richmond on Tuesday. He's driving back Tuesday. He's going to be there the rest of the week. So this is just for everybody here in Winston-Salem to get a flavor of Derek and see what he's about and ask questions directly, which I think is very important. We're also going to try something different at the breaks. Right before you start exercises, we are going to switch off the feed, which is one way, unfortunately, and we're going to open up Skype. And we're going to try to have it two-way, so we can actually have a voice, or they can have a voice. So it'll be more interactive, at least for the Q&A portion before you start your exercises. And if you have any other ideas, please feel free to speak up. We're trying to make this as effective as possible. And without any further ado, here's your instructor today.
Hello, everybody, especially in Winston. I'm the one you've been watching. I appear, apparently I was very dark and sort of whitewashed in a shadow. I'm actually a real human, not an automaton of any sort that I'm aware of. All right, let's jump right in. So we left off Friday with actually an exercise, because I talked about the motor vehicles, we'd gone break with an exercise, and I've actually brought up on the screen here. I now understand what you mean. It's actually hard to read the screen from the corners. That's quite a pain. But it's on the stream right now, so you can see it at least that way. So we had the motor vehicles, we had a fuel-efficient vehicle and a super-fast vehicle, and the exercise was to change that move method from void, right, because you could just move some quantity and it would decrement the fuel, and actually make that return true or false. We did that because if you think about it, you can't just move a vehicle forever, right? You can't just accelerate forever. You can't just say go and it works forever. You can actually deplete fuel and be out of fuel. So we decided to change that move method.
I forgot to tell you, we didn't actually do the exercise.
You didn't actually do the exercise. No problem.
Yeah, could you review, just over, at least tell them what it is?
Sure. All right. So let's start from scratch. Let's go with motor vehicle. So the actual motive was to learn about inheritance, right? That's the actual technical term in an object-oriented language where you can have child classes of a parent class. And so the exercise was to really figure out how all that works, maybe type up some things with their own fingertips. So I brought it up on the screen. I do have a motor vehicle abstract class. So you can, I'll use the cursor to sort of point this out, make sure everybody's on the same page. Up till this point, we had already created classes, right? We had that adder class, we had some others. Those were normal classes, standard reference types. Don't forget that all classes are reference types. And we had set some properties and called some methods on it. Not too complicated. But then we wanted to talk about these child classes. So remember, an abstract class is a class that itself cannot be instantiated. You can't call new on it. But it basically contains code that is shared by all of its children. The real goal here is to not have to copy and paste your code multiple times. If you have a lot of disparate types, a lot of different types you're going to create, but they have a lot of similarity in how they're coded, one way to help reduce code duplication is to use parent classes. So in this case, we ended up wanting a fuel-efficient vehicle and a super-fast vehicle, and both consume fuel at a different rate. And I'm not sure if you were able to catch the stream on Friday, but I created those classes without a parent class first. So I already had a fuel-efficient vehicle and a super-fast vehicle. They both had an add fuel method and a move method. And they both worked. They were actually finished. But if you remember, and I hope this part of the stream was on, I tabbed back and forth. Did you guys see that? Where I would tab back and forth between the classes? That's unfortunate. So I basically brought up both the fuel-efficient and super-fast, and I did this. If you look at the screen, I did this for people in Richmond. I did this for about 3 minutes straight. I just sat here and clicked between them while I was talking. And the point I was proving is that on the screen, they weren't changing much. There were only 3 or 4 lines that varied. And so you ended up in a situation where the two classes had a lot of duplicate code. And if you ever Google about duplicate code in software development, it's always bad. And there's nothing but negative articles on code duplication. The internet's filled with them, and there's a reason for that. It haunts us. It might seem kind of easy at development time to copy and paste some code and have it duplicated, have some business logic duplicated. That will come back and bite you every time. It will bite you or your teammate who will come over and bite you. It's usually very bad. And if you think about it, it makes sense. If you have the exact same business logic in 18 different places in the code and the customer wants it changed, and you're tasked with changing it, how do you know you've gotten all 18? You might get 17 of them. And then you'll test it, right? You'll test your code to the best of your ability. If your tests don't catch that 18th scenario, it goes up to production and it's broken. But it's only broken for a rare case. So that's really a pain. So that's really the most general outcome of duplicated code is when you go to change it later, you don't change it correctly. And by correctly, you only change it in 3 out of 4 places, 17 out of 18. So we work extremely hard as developers to deduplicate code, to keep everything only coded once. And we're willing to go to very, very far lengths to get that done. And one of the ways is base classes. So I had gone back and forth between the code examples, and you're not seeing the beauty now because I've already recoded the software here. I don't have the original code, I apologize. But I tabbed back and forth, and there was so much duplicated that I finally said, is there a way we can duplicate this in C#? And the answer was yes. And so I ended up creating this motor vehicle class. So I created the file, and the one method that was identical in both of the original vehicles was add fuel. How you add fuel to 2 different vehicles is effectively identical as far as the software is concerned. They both just maintain how much fuel they have, and the act of adding it is just an increment. And that increment's occurring here on line 12. So because that method was fully duplicated, I pulled it out of those 2 other classes and put it here. And I also pulled out the move method, but only part of it. I pulled out the decrement functionality, which is on line 17, but I added what varies from child to child class. I added that as an abstract method on line 8 called calculate fuel depletion. So I pulled all of those into this parent class, which I called motor vehicle.
What is abstract, by the way?
Abstract, so you see it on the screen twice here. So although it's the same keyword, I want you to think of it as kind of declaring two different things. In the case of line 5, what we're saying is the class itself cannot be directly instantiated. I cannot go to my program.cs and say var x equals new motor vehicle. I'll get red squigglies. That's not allowed. It's written that way because what you're saying when you, on that line 5 is there has to be a child class in play. And the reason, in this particular case, that we need a child class is because of line 8, which also has the word abstract. This word abstract means all child classes that derive from motor vehicle must implement this method. They must have that method on them. And I'll go to the two vehicles right now. You can watch the screen. You'll see that that is in fact the case. Both the fuel efficient vehicle and the super fast vehicle have that method implemented. They were required to do so. And just to show you what would happen if they weren't there, I'll delete it and pause for a moment, and you'll see red squiggles appear. Remember, red squiggles always mean you're not done. It won't even build. The IDE is telling you you've missed something. In this case, it's missing a method that I just deleted for demonstration purposes. I'll undo and put that right back, and now it's buildable again. So it required me to put that on. So when we go back to the motor vehicle, what we're saying with this abstract is you have to implement it. And the reason I wrote that line 8 is because of line 17. Because I wanted the active moving to decrement at a different rate per vehicle type, I needed to defer to that child class the work. Basically means I need that child class to have a method on it called this. It needs to look like that. Its signature must be int calculate fuel depletion. So here, especially in Winston, because you didn't see the end of that on Friday, any questions about what I've said so far about these two? Yes, go ahead.
I was going to say, would you kind of go a little bit deeper into explaining abstracts?
A little bit deeper into what that means?
Yeah.
Maybe if you compare it to interfaces, how they're both kind of contracts.
So this abstract, I would agree. When it comes to line 8, it's kind of like a single method interface, in this particular case line 8, where we're demanding on line 8. When we write the motor vehicle base class, we're saying that all child classes must conform to a contract, and that contract is pretty simple in this case. Be sure to write this method. So we're just making a demand on future code. Now in a demonstration like this, right, we're doing a lot of small classes just to sort of learn all this. What you have to sort of pretend is you could be making the motor vehicle base class and you're working on a team, and there's going to be 10 different vehicle types, but you actually don't know right now what those types are. So you need to be able to create the common code today, which is add fuel and the partial work here in the move method, but your teammate might 6 months from now create a third, fourth, and fifth vehicle. Well, how does that teammate know how to write that child class correctly? How do they know what they need to implement? Well, here in a language like C#, unlike something like JavaScript, we can kind of make demands on future development. We have this contract here similar to an interface method where we're saying you must have that method present. And I can demonstrate that. Instead of just talking, let me pretend to add even a third vehicle type. So I'm going to add a new class to that V2. And I know it's going to be a motor vehicle, but it could be anything. So somebody just throw out to me some other motor vehicle that requires fuel. Truck. I'll just call it truck. So I'll create the truck class. And this active adding classes probably works faster for you all. My laptop struggles when I'm streaming. So there's our truck class. I'll clean up the stuff I don't need. So right now I can put anything I want in this class. This is a standard run-of-the-mill class. I could do whatever I wanted with it. Notice there's no red squigglies. Everything's happy. I can build this software and I could run it. But let's pretend we're 6 months down the road a previous teammate wrote motor vehicle, I'm required to create the truck class, and I know that I'm told, hey, we already have a motor vehicle base class, be sure to derive from that. Okay, fine, I'll follow my orders. Oops, I'll do motor vehicle. And what you'll notice is truck immediately becomes red underscore, or red underline, red squiggly. If I put my mouse over it, it says, truck does not implement inherited abstract member motor vehicle dot calculate fuel depletion. It's telling me I'm missing something. If I try to build this software, just to show you, it will fail. At the bottom left, you'll see, eventually you'll see build failed. My error list will open and it'll have that same error message on it. This is the compiler saying I refuse to generate the code, to actually compile it from your typed code into that intermediate code, that machine code. It refuses until I do my job correctly. So what's helped me is, because I'm a future developer in this hypothetical situation I put together, I didn't know exactly what I needed to do here, but the language is actually helping me know what to write. And as I was showing last week, I can hit Control Dot, and it will actually offer me suggested ways to fix the problem. And its very first solution is to go ahead and type out the method I'm missing. So in this case, truck, we could do anything here. Anything that returns an integer we could do in this method. We could write 1,000 lines of code that does this really complex fuel consumption algorithm, or we can cheat like I did with the other two vehicles, and I'm just going to return an integer. And now I'm done. So now code elsewhere can instantiate trucks, and trucks can have fuel added to them. You'll notice on the screen, truck does not have an add fuel method on the screen. Like, I can't see it. Nowhere on the screen do you see right now add fuel. But there is an add fuel method, which I'll prove in program.cs equals new truck. I'll instantiate the truck, and if I hit that dot on that variable, I see add fuel. So where did add fuel come from? It comes from the parent class. So any child class just inherits, and that's what we call it, inheritance, inherits all the properties and methods of its parent class. That's how we can sort of deduplicate that code, not have duplicate code in the system. We can create new vehicles that have differing ways of depleting fuel, but all the other code is identical. And I'll go to motor vehicle here to remind you what was on it. Add fuel and move are both there. And they're both on truck implicitly.
So would you kind of like try to get straight in my head, like abstract class is almost similar to like private in a way?
So the question is, and I'm always repeating the question for Richmond,
Yep.
is the question abstract kind of like private? I don't really see a correlation there. Private is generally used, and I might have an old example here. Private is generally used to hide something from everybody but that particular class. Let me see if I can find an example. There we go. So in an old example, I've opened up some old code from last week. I had pickup truck as iMotor vehicle. You see this is private int cargo. What this means is if somebody tries to instantiate a pickup truck, they can't hit dot and see the lowercase cargo. That's what private means, is it's really hidden. And there's a term for this sort of thing. We call it encapsulation. That's the technical term. In this particular example, the private is helping us reach the goal of encapsulation by privatizing certain fields. And what you haven't experienced yet, right, because you haven't been in the field a long time, the larger a project gets, the more confusing it is to work on. So when you think of hundreds of thousands of lines of code, what if every class exposed all of its properties to every other line of code? What if every single line could touch every other line? What that would mean necessarily is whenever you opened a class and were working on it as a developer, you had to remember 50,000 variables in the system. That is impossible. Humans have a working memory of 7 plus or minus 2. Studies have been done on that, maxes out at about 9. Once there's more than 9 things in your brain, you're lost. That's just how humans are. So we can actually have features in our languages that help us reduce how many things are in our scope from 50,000 down to like 3. 3 is nice and comfy. Do you have a comment or question?
Could you give a real life example on what abstract means, like a metaphor or something?
Maybe just inheritance in general, because I don't think that's clicked yet.
I'm open to suggestions.
I think you're doing a great job, but I think they need to see it through a few times.
Okay. Oh, protected. Great question. So the question is, what does protected mean? So we actually have 4 keywords we use in the language for on this topic of encapsulation. Public, we've already talked about. Public is exactly what you would think it was. Everybody can see it. Private, which I just talked about, means only me. So let me reopen that up. Pickup truck. This means only pickup truck can see it. Okay? Protected is a little bit higher than private. It means that, in this case, I've opened up motor vehicle again. It means motor vehicle can see it, but all of its children can too, but nobody else. So in this particular case, I had the calculate fuel depletion as protected, which means motor vehicle can see it, which you know it can. That's happening on line 17. It has access to it right there on the screen. But when we go to one of the child classes, I'll go to the fuel efficient vehicle. You'll see this is protected. It can see the thing it needs to override. So it's very common to see protected abstract, because abstract demands that the child do it, and protected means that only those two can see it together, only the parent and the child, but nobody else can. So once again, if I were to go to program.cs and look at truck, I can't see the calculate method. I can only see add fuel and move, but I can't see the calculate. That's because it's hidden from everybody except motor vehicle and the child class. There is actually a third one called internal, which means everybody in the current project can see it. That one's not used as much, it's not as critical. The public and private's the real critical ones. Public, of course, meaning everybody, which is an important declaration to make, and private, which means nobody except me. Those are the two extremes of that spectrum, and they're used the most. Do you have a question?
Yeah. So earlier last week we went over interfaces.
Yes.
And now we've touched on inheritance, and it seems like they're very similar to me. So when would we use inheritance over interface, or is interface a
Yes.
type of inheritance?
Great. That is a superb question. I'm going to repeat it for Richmond. The student is noticing that there's a lot of similarity between interfaces and inheritance, and the question is, when do I use one over the other? And that is a very, very good question. Let's talk about the easy part first. I'm going to go to an old example from last week. I had the aggregation work we were doing, and I had an I aggregate function. Interfaces are only a set of promises. It's just a promise. So in this particular case, it just demands that whoever implements I aggregate function has an insert method whose signature is void and takes in one int parameter. It also must have a calculate method that returns int and has no parameters. The thing about an interface is you cannot add code to it. You'll notice that these look like the signature of a method but don't have the little curly braces. And if you try to add one, I'll do it here. Don't follow along because it won't work. This won't work. You can't do this. Even if you try to make it public, no matter what you try to do, put your mouse over it, it actually says interface members cannot have a definition. That means the actual body of the method. So an interface is a promise only. It cannot have code in it. That differs, let me clean up this code so it will build. That differs from a parent class. Let's go to motor vehicle. It differs because if you look at this abstract motor vehicle class, it has code in it. This add fuel is a perfectly complete method. Not only does it have a signature of void add fuel int, it also has a body of a method. Line 12 is functional code that's going to run. So they're different in that way. So the interface is only a promise. The parent classes can have code in them. What your brain has successfully done, which is cool, is you found a commonality though. This line 8 is very interfacey, right? It has a promise in itself and it does not have a body of a method. You have correctly identified that there is overlap. So the question is, when do we use one over the other? I have a very strong opinion on this, shared by a good portion of developers, although not 100%, and that is I always use interfaces until I know I need the code to be shared. Most of the problems when I'm creating, we call them abstractions. Interface is just a kind of abstraction. Usually I'm able to get it done with interfaces. Usually promising the signatures of methods and properties is enough. But when I need logic to be shared, an algorithm of some sort, I have to have that base class. And line 12 is a great example, and the first half of line 17 is an example. I could not have written these lines in an interface. They are actual functional code that executes. Interfaces are just about signatures of method, not actually how they work. But good catch. There's a lot of similarity and differences, which makes learning both of them at the same time a little tough because there's a lot of overlap. But it's like that for that reason. Sometimes all you need to do is enforce a signature. Other times you need to actually write code that is shared by the child classes, and that's how you pick which one you're going to work on.
I've heard a rumor that the back of the room is having trouble hearing you.
You heard that rumor, huh?
I did, yeah.
All right, I'll try to raise my voice. I'll try to project. That's not really my strong point, but I'll try. Yes, in the back. Another excellent question. Can we have more than one parent class? The actual answer is no. And this is different with interfaces. I actually showed last week we were able to put lots of interfaces on. I had a very funny example that I think I ended with. See if I can find it here. It's one of the latest console labs. I give up, I can't find it. I did show an example last week. We could have multiple interfaces. It's pretty much unlimited as far as interfaces. However, C# is what we call a single inheritance language. That's one of those common terms. You can only have one parent class. Most OO languages generally follow that pattern, and C# is one of them, that we can only come down from one class. And the reasons are pretty technical, but if maybe on your drive home today, if you think about it, what would multiple inheritance look like? It's extremely confusing. It actually makes the code very hard to understand. So you are sort of chained in. Once you pick a parent class, you're stuck with it. And that can be good or bad. But interfaces are much more flexible. That's another reason I sort of try to solve my technical problems with interfaces, because I don't force other classes to only come from me. They can have multiple interfaces. Good question, though.
So can you section out your code by using a parent class and interfaces, using the parent class for logic-based inheritance, and then put an interface on that class that's using the parent class?
Yes. That was a long question. I'm going to try to find the example first. I actually did find the vehicles. So I actually had an example in this alpha, and it would take me a moment to find it, but I did have an example where the parent class actually had an interface attached to it. So, and I know I didn't re-summarize the question for Richmond. I'm just going to answer sort of open, sort of a broadsword answer. You can mix and match. You can have interfaces at any point in the class hierarchy, so at the parent class or the child class, and the code will simply force you to follow that contract at that level. I'm going to do a search real quick just to see if I can find my example.
I want to point out that the syntax is identical between interface and implementation and inheritance, at least in C#.
Oh well, I won't be able to find that example, but I can come up with a new one. If you want me to, I can do that. If you want me to, you can mix and match though. So I have shown only a motor vehicle and child classes. What I have not shown yet is you can go any quantity of levels deep. So you can have as many parents and you can go as deep as you want. And usually on a team, once they're really comfortable with object-oriented programming and inheritance, they'll actually build them pretty deep, which means, to your point, they can actually be attaching interfaces at different levels. And you can mix and match. I mean, you could really go too far in some cases. There could be an I motor vehicle I attach here that has an int calculate fuel depletion on it. And I would have to boost this up to public. I mean, you can really go crazy. So the combinations are almost limitless with the exception of only one parent class can you inherit from. But it can be a lineage of them. So you can effectively be inheriting from 20 if it's 20 levels deep. You just can't have multiple parents at any given node in that hierarchy.
Sure.
It can get out of hand. I don't want to show examples like that because generally on the job I try not to create hierarchies that deep. I find them kind of confusing because you have to sort of to know when you're working. Remember, when you look at the child class, you can't tell what methods are on it. The only way to do it is to navigate up the hierarchy. I can put my cursor on motor vehicle and press F12 and it'll take me up. But if it's 20 levels deep, I have to sort of navigate all the way up and memorize or write down on a notepad what methods are participating and why. So I generally go for shallow hierarchies. That's what I personally prefer. That's what I suggest you do as well. Don't get too carried away with the cool features. It'll come back and bite you. Any other questions on that? Please feel free. This is actually one of the last big language features we're going to talk about before we move into some cool stuff. Like right now we're just learning what if statements are and switch statements and how you build a method. This is really the big one. Soon we get to go to some more fun things as far, in my opinion. But you will need to understand this because we're going to be reusing it over and over. So are there any other questions about this? Yep.
Can we do one more example using parent classes and inheritance together?
Sure.
Not inheritance, interfaces, excuse me.
You want interfaces?
Yes.
Okay. So, yeah. Excuse me?
So that's the whole, like, parent, it's not just interfaces, it's, like, abstract methods can inherit from each other.
Yes. Yeah, they can go down the hierarchy, and because you can do multiple parents and children, like in a lineage, that's what I like to call it, as a lineage. Each child having one parent, but it goes pretty deep. You can have something be abstract at the second level and continue to be abstract till the seventh level. However many deep you want. I don't really recommend that. You're probably going too far with the language. But you can have, like I was telling him, abstract methods on parent classes and required methods from interfaces of different signatures at all ports in the hierarchy. Now, if that sounds confusing, you're correct. Generally, when I'm even working with experienced developers and they've created something that works, but it's kind of complicated that way, I'm usually giving them feedback to simplify it. Because just it's one of those things. Just because you can doesn't mean you should. I only use inheritance when I really, really need to force something. My motor vehicle example, I did have a reason to force something upon them. I had shared code, and I had something that I needed them to determine and vary based on the child type. So that was a fine time to use that. But in a different example I did last week, which is in the vehicles class in that alpha solution, I had car and bicycle classes that did not have parents. They only implemented interfaces because there was not a shared set of code. But I had a lot of interfaces. I don't know if this was on the stream last week, so I'm just going to go over it real quick. I created a bunch of funny sounding interfaces. I-breakable, meaning it has brakes, so it has a method for hit the brakes. I has passengers, had no methods on it. People were giggling there too. It's okay to giggle at these. These are funny names. I has wheels has nothing. I two-wheeled has activate kickstand. Most two-wheeled vehicles need kickstands of some sort, be it a bicycle or a motorcycle. So I put all these on, and then I created two classes, car and bicycle. And I only put onto them the interfaces that made sense. So cars have brakes, they have wheels, they have passengers, and they are motored. So they had all four interfaces attached. Bicycles are different. They do also have brakes and wheels, but they also have a I-two-wheeled interface, but you notice they're missing I-motored. So I threw this one together real quick. Somebody asked a question in Richmond that sort of drove it. But you can see that you can attach whatever interfaces you want. But I did not have any need for parent classes here, so there are no parent classes in this particular example. And that's because there was no actual shared code. There's only shared signatures of methods. Throw. That is our next topic. So once we're comfortable with the inheritance, we will be talking about throw. That was actually typed by Visual Studio, so to make it build. So I couldn't help but have that on the screen, but don't look at it too close yet. You can look at it if you're already sure you know about inheritance. But if you don't, ask me more questions about inheritance. And we did have a request for another example. I'll probably do that. Go ahead.
Go ahead with your example.
With the new example? Okay. All right.
You might want to call Richmond. If they have any questions, we're going to try to get to them without we just need to put it in Slack.
Could you prompt him?
Yeah. I'll put it in Slack.
Ali, do you have any suggestion for maybe a cool scenario where I could show off some more interface and inheritance stuff?
It's interface and inheritance.
I think that's what they want, a combination.
Yes, though. It's Monday morning. What did y'all do this morning? You got up. You probably got some caffeine of some sort. What else did y'all do? What do y'all want to talk about? We can. That's the beautiful thing about code. You can do it to model anything in the world.
Do some sort of breakfast.
Breakfast. There you go.
Breakfast.
That's a rich topic.
How would I model breakfast? Tell me about breakfast. Let's talk about whenever I'm trying to design software, I'm always interested in nouns and verbs. You know, what are the things involved and how do they operate? So let's talk. What'd you do for breakfast?
Thinking chickens and eggs if you're talking about breakfast for inheritance maybe.
Okay, and
So you pour the milk.
okay, now we got verbs. We got pouring milk. Okay.
Nouns specifically would be like eggs or food.
All
let's
right.
say.
Got eggs.
So let's say eggs, cereal, orange juice.
All right, orange juice drinking. Right.
Input parameter of hunger.
Got it. Okay.
Hunger could be number, could relate to the amount of eggs we eat or the amount of food we consume.
Gotcha.
Or
Okay.
email.
What's that?
Or email.
Sure.
You'll
So
have
you're talking
to-
about implementation details. I'm trying to get spec here. That's what we do though. We're always like, as developers, we're like, what's the implementation detail?
Caffeine level, it breaks every time if it's not sufficient.
I like that. I heard open the fridge and what else?
Just for the refrigerated items.
Yeah.
Open the fridge.
Gotcha. So we're starting to talk about a workflow.
Cook oatmeal.
Cook oatmeal. Okay. Cooking eggs. This is good because we want lots of examples because what I'm always trying to find, and it goes to the question I had earlier, what's similar? So we cook eggs, we cook oatmeal, we don't cook cereal. Well, usually, let's say no. Might cook oatmeal. I don't think we do that. I didn't cook mine this morning, so that doesn't sound good. What's that? Washed blueberries. Okay, so we have fruit preparation. Okay. All right.
In the blurred fog, you have to find the button to push for coffee.
Right. Right. Attempt button push is what we'll do. Okay. Gotcha. Okay.
Caffeine fog.
I think I want to go with the. I think I want to go with cooking. Let me think for a moment. I want to really come up with the best example I can of all this. Okay, the first one, I'm going to create an interface, and I called it iCookable. I'm just going to talk about the cookable ones right now. I'm going to leave cereal and stuff out. We're going to narrow this down a little bit. I don't want it to be actually be really complex. So iCookable. And what I'm going to do is I'm just going to have a method on there called cook. So what am I saying here? What do interfaces do?
Any class with that interface will have cook.
That's right. Anything that implements this interface will at least have a cook method. That's right. So all I'm doing is creating a contract. Somebody's got to fulfill it, but I haven't decided who yet. It's just going to have a cook method. No big deal. So let's do a class. I'm going to call it cook process. The reason I'm doing this, I'm going to create a class that demands what has to be done to prepare something that's cookable. And we'll probably have some code in it as well. So I'm going to make it a parent class. I think I'm going to end up putting code in it. It's going to have the steps that are required in the order in which they must execute. Because when you cook something, we're going to have turn on stove, we're going to put this. It's kind of a process. And it's like anything else in life. Once you've done it a while, it's kind of hard to break the process down. It's sort of muscle memory. But cooking is a process. If you just put the food on the stove and do nothing, it doesn't get cooked, right? It's good. There's a process to it. So we're going to have a cook process.
I'm sorry, what did you make this begin with, an interface?
The very first thing I created was an interface. Sorry, yeah, the very first thing I created was an interface, iCookable. And all that had on it was void cook. So it's just saying that anything that implements that interface is guaranteed to have that method on it. Not how it's implemented, just promises to have that method on it somewhere. And I'm just now creating a new file called cook process. This is a class, and I'm actually going to have it implement that interface. iCookable. And immediately I get red squiggles. Why do I get red squiggles?
You don't have cooked yet.
I can use Control Dot and have it write out the interface for me. So now we can actually prepare to write some code in here in this parent class. So I'm just going to choose a few steps that are required for cooking. Right? These are things that all child classes must do, because I'm going to have different child classes per thing. Maybe cook oatmeal, cook eggs, whatever. That'll vary a little bit. So what must they do? Well, the very first thing I'm going to have, let's see, I'm trying to decide if I want to always cook on the stovetop or have a microwave. Do I want the type of cooking mechanism to vary? I think I'll say yes. So I'll do protected abstract, and I'll have turn on whatever the cooking mechanism is. I'm just going to call it a cooker. So that's got to be done by the child class. Oop, what'd I forget? Forgot to make the class itself abstract. So this is good. You'll see that the IDE has told me something I forgot to type. When I put my mouse over it once again, the method is abstract, but I forgot to make the class abstract. I just forgot to type it up here. That's easy though. I'll just type it.
Why is that a problem?
Why is that a problem? You cannot put an abstract method on a non-abstract class, because otherwise you could directly instantiate the class and not have a child to implement turn on cooker. So the language is just preventing you from setting up a situation that's not really logical. You can't demand a child class do something without also demanding child classes exist. So they go in line with each other. The good news is you can see it's kind of hard to make the mistake. If you try to type it wrong, it will complain. You can do the reverse okay, but my mistake was that I left this off. But that's not something to really be scared of because the language never works. Question in the far back, please.
I might have missed this, but if all child parent classes have to be abstracted with a protected functional method, or?
Yeah, the question is, do all parent classes have to be abstract? The answer is no, actually. You can get away with the language allows you to derive from classes that are not abstract. So you can have children of non-abstract classes. The issue is you could have never on the potential parent class had something abstract for the very reason it's red squiggled right now. So it's possible, and people do that, and I'll probably do that at least once later this week just to show you it's possible.
Could you give an example of maybe cars? I was thinking like a base model Corvette and like a souped up Corvette or something, where they both could exist. One inherits everything except like the trim.
I could. I mean, we're working on. I want to do one thing at a time. Do we want to stay on this one, or do you want me to go to the other one?
What's your shot?
Okay. So in this case, I made the mistake. Let's stick with breakfast just because we're all thinking about it. It was the most recent thing we talked about. I'm going to put abstract right back in there. So what might be something we do next? We have to apply the food. Let's go ahead and do that. Predicate abstract void. I'm just going to put it, I don't know what else to call it, apply food. I want to put it in or on the stove. I want to apply the food to the cooker. And I'll add one more method. We don't have to get carried away with the example. I'm going to turn off the cooker. That'll be my last thing that the child class must do. So now, where are we now? We have a parent class. It obviously is a class that represents a process. That process is the act of cooking something. It itself is abstract, so you can't use it directly. And child classes, they have to determine how we turn on the mechanism and how we apply food to it and how we turn it off. That's what they're responsible for. Our cook process is responsible for at least one thing, and that's the order in which these occur. It would not make sense to the first step be turn off cooker. Like if I type that right here, like that doesn't make sense. Oh, turn off cooker. Now that would work, but that doesn't make sense. That should not be the first step. That should be the third step in a 3-step process. Now in this case, you're probably looking at this thinking, Derek, that doesn't do very much. And you're correct. It's not a complex example, but I want to re-emphasize that this parent class is performing something, a service here. It's not too obvious on the screen, but it's what steps are required and in what order they must occur. And that order is critical. So what's cool about this parent class is it can make sure that child classes don't do things out of order. So it's actually providing a pretty valuable service. Now, in a real world scenario, we would probably have somewhere right here, lots more code. It would probably be doing something more impressive. But I want to emphasize that simply the order in which code executes is critical. And that should make sense to you when I say it. The order in which something executes is critical. Of course it is. Everything in life, the order is critical. So that's a good enough service. And now let's add our first child class. I'll do oatmeal. I heard that one. We'll do oatmeal cook process. It's a common convention to name the child classes based on their parent class or interface. It's not always done, but I'm doing it right now just because it's not too long of a name. I'm going to make it derived from that parent class, cook process, and we get red squigglies. And I'm going to go around the room here, and I'm just going to, as I ask questions, point to people a little bit. And I don't know your names. I apologize. You, sir, here on the left, next to Kelly. Why do I have red squigglies? What have I not yet done?
You haven't initialized or identified oatmeal yet.
Haven't identified oatmeal yet. Well, what's actually missing on the screen?
I can't tell you.
Okay, no problem. To his left, you, sir, would you like to take a guess?
Say your names before you answer.
Yeah, I apologize. I don't know anybody's
It's Brian
name.
and it's Adam.
All right, Brian and Adam. Thank you.
Is it the variable that goes in between the squiggly brackets?
Variable, close. What's something else that might go there? Show of hands. Who wants to help him out? Let's do. There's someone in the back, very far rear. I want that. Give me that one. That person.
We need to return the method for this class.
I like that answer. We're missing the methods. That's a very good. That's a perfectly fine answer. And you can tell if you were following along and put your mouse over it. Does not implement inherited abstract member. Blah blah blah. Turn off cooker.
And that's what links it to the interface.
To its parent class, yes. Interface is actually, you're really almost right. I mean, that's a very close answer. I would still give that an A. Because since these are abstract, they're pretty much fulfilling the A contract. So it's very similar to an interface, but it actually comes from the parent class.
Okay, good.
And remember, I can hit hotkey to make that type for me. In the blue shirt, to the left, you're next. Yeah, I'm going to go clockwise, so you'll know when you're coming up. Get ready. What's my hotkey? Do you remember? Control period, that's perfect. Implement abstract class. Boom! Types it all out for me. Now, Visual Studio generally does these in alphabetical order, so it will put them on the screen in a weird order, but you can see all of them are there. And so, just because I'm going to end up running this to sort of show that this code actually works and that everything we're doing is legitimate, I'm just going to directly write to the console, so we'll be able to run this later and it'll look good. So let's go ahead and do some write lines. Turning on cooker for oatmeal. And I'm going to cheat, do a little copy and paste just so I can type more quickly in front of you. Turning off the cooker. Actually, I'm going to say, I'm going to call this a microwave. I'm going to put mine in the microwave. How about that? I'll do microwave for the oatmeal because I'm impatient. And here, I'll copy and paste again.
There's a question from Richmond.
Okay.
It was said that you name child classes after parent classes, but is there a way to remember a parent class, like when we put the I in front of an interface name, like starting a parent class name with a P or something?
Gotcha. So hopefully everybody here heard the question. It's about naming from parent classes. That's actually pretty common. It will vary from team to team. It's very common for people to call the parent class base. So many teams will have called this cook process base, B-A-S-E. And the reason they refer to that, it's very common in all these OOT languages to call it a base class. And you can actually, there's actually a keyword in C# for accessing base class members directly, and it's called BASE dot. So if you do base dot in a child class, you can see all the way up the inheritance chain and all the methods that are at the immediate parent or higher in the hierarchy. So yes, some people do that. I personally don't, so I'm not going to do it here. I do follow the Microsoft convention for interfaces and put capital I's in front of them, but I usually don't put the word base on base classes. So you won't see me do that.
Another advantage of not having crazy deep hierarchies.
Yeah, balance commenting on crazy deep hierarchies. You know, if you go really deep, what are you going to end up naming all these things? It can really be quite a pain. So I go for shallow hierarchies. That's what I do. So we've completed our oatmeal cook. I'm turning on the microwave. I put the oatmeal in the microwave and I turn it off. Now, Visual Studio did arrange this by alphabetical order. You could rearrange them if you want. The order in which methods appear in C# does not matter. So put them in whatever order you please. It happens to be in alphabetical, and that's good enough for me. Now, this really won't be impressive without at least one other class. So I'm going to create another class. And this one will be for cooking eggs. So I will do egg cook process. So to his left, sir, in the glasses, yes. What do I got to do?
Colon.
Yep.
Cook process.
Colon cook process, right on the money. I'm going to see red squigglies. I've already asked that question, so I'll go ahead and do the control dot. Yep. Turn on cooker. This time we'll turn it on differently. Once again, we're cheating with right line just to make it easy. I'm going to do turn on the stove. Turn on the stove. I'll do past tense. I'm doing these console right lines because eventually I'm going to go to program.cs and show you all this running. Yes, go ahead with the question.
Because the parent class already has it in order, the child class doesn't have to have an order because it already knows it.
The question is about method ordering. Method ordering does not matter in C#. There are some languages that do matter, but here it does not matter at all how they're defined here. They will get run in the order in which the cook process base class demanded that they run, which I've pulled up on the screen here. It will be turn on, apply, turn off. And that will be invariant among all child classes. It will not change from childhood class to child class. They don't even have the ability to determine that order, right? Because it's been deprived of them. They only know how to do each individual step, but they're not responsible for its order. So let me finish out this. Put eggs in skillet. And that's good enough. Now we have two processes. It really doesn't make too much sense not to have at least two child classes or two implementers of an interface. So I wanted to have at least two of them. So now we have all that put together, we can go to our program.cs. I'm going to make my console app the startup project, and we can play with this. Oops. Oatmeal process. Not that one. What am I? Oh. If I could spell, that would really be helpful. There we go. Perfect. And just to sort of show why the parent class is, actually I don't need to go very complicated with this, never mind. I'm just going to use both these classes directly and we'll see how they operate. So I've got one instance of each, right? One oatmeal process, one egg process. And now I'm just going to call them. Remember that they both implement the iCookable, so both of them are going to have a method on it. To his left, ma'am, what method am I looking for? Nah, but I'll give you a hint. It's on the interface. There we go. You're good. .cook. I'm not going to be supplying the actual turn on and turn off because just the act of calling cook, and I'll use F12 to jump into this, will call those for me. Right? I'm calling a method that's going to call 3 other methods, and which 3 it calls will vary by type. So I can call cook on both of these. Egg process.cook. And remember, I'm always going to use that console.read key just to pause it so it'll stay on screen so you all can see the outcome. I'll run this, and we should see both processes run in the correct order with the correct text for what they do. Remember that oatmeal is happening first. I'm going to move it to the side so we can sort of look at the code. We did oatmeal first, so we turned on the microwave, we put oatmeal in the microwave, we turned off the microwave. So in that particular case, this oatmeal cook process with its specific methods, and I'm going to get them all on the screen here, they ran first, and they ran in order because that parent class determined the order. I'm using the parent class here. The real value it brings is that it determines the order and the child classes can't. So I could distribute this code and other developers could add thousands of different processes and they could never get the order wrong because they're not in charge of it. My parent class is in charge. As long as they derive from that parent class, it's guaranteed to operate in the correct order. And because I had the iCookable interface, the actual calling code in program.cs does not have to call 3 methods. It calls one. It calls one. Those 3 get executed in the correct order. And as you can see, even the eggs came out correctly. Turn on the stove, eggs in the skillet, turned off the stove. And we'll follow that. So I'm going to stop this. I'm going to restart it. And I'm going to use a breakpoint. I highly recommend as you're learning this stuff, especially this inheritance stuff, this is probably the most confusing part of learning an OO language because there's not as many real-world examples. Like some of this stuff's very esoteric programmer, software development tasks. Use those breakpoints and step into the code line by line. So let's run through this again. And I have a breakpoint on the very first cook. And I'm going to press the hotkey F11. F11 is in the debug menu here. It's a shortcut for step into. And what that means is it will go directly into the method every time I hit the F11. If there's a method to go into, it will actually dive into it. So I hit F11, I jump into cook process, line 12. So it opens up the file for me. And it's going to invoke that turn on cooker. Remember that turn on cooker is abstract, which means it's actually going to now, the next time I press F11, it's going to jump into the correct turn on cooker. Remember that there are 2 implementations. There's one in each of the 2 classes, egg cook and oatmeal cook. So it's going to jump into the correct one. If we press F11, we're in turn on cooker in oatmeal cook process. We're exactly where we expected to be. So we turn on the microwave. I'm still pressing F11. We come back out to the cook process. And this is executing. I know this can be sort of weird to follow. Like if you're new to Visual Studio or new to development, you're using this F11, it's sort of jumping around in files. But what it's showing you is the truth. This is exactly how the code executes as the computer executes it at runtime. It happens real fast. We're slowing it down and sort of watching it as it works. So we'll apply food for oatmeal. That's going to put it in the microwave. Turn off the cooker or turn off the microwave. Press F11 and we are out and done with oatmeal. And then we'll do the same thing with egg process. So when I press F11 here, I go into the same parent class, cook process, but I'm going to go to a different turn on cooker. I press F11, I'm now in egg cook process. So it's calling the correct child methods based on the type. I just F11 through it, speed right along. And we knew it worked correctly already because on our output we got the correct steps for those meals. How is that example? Questions? Awesome. That's good. Check mark.
So iClickable is the interface, and we have connected the interface to the parent class.
Yes.
Does that mean that all the children of that parent class also must have Cook in it? So I guess what I'm asking is,
that's a good question.
If you put the interface on the parent class, does it apply to every single child class?
Gotcha. So for Richmond's benefit, we have an iCookable interface with Cook on it. We applied that to the parent Cook process class. And the question is, does that mean that all child classes have Cook? So the answer is yes, but I want to emphasize why it's yes. If I put iCookable at the Cook process level, the Cook process class must have the implementation, so children have it implicitly. I cannot put iCookable on the parent class, delete this method, and have Cook process be buildable. You'll notice I got red squigglies. I could get away with it. There is a cheat I could do, and just because you asked the question, I'll show it. I'll begin to show it, but we're not going to go all the way. I can do public abstract void Cook at the parent class level, and so what I'm saying here is Cook process follows iCookable. It has a Cook, but it hasn't implemented it, and it demands all of its children do. However, that's a bad way to code this example because then I lose the reason I put Cook in the base class. So I'm going to delete that.
Sure.
So you can get it done, but if you think about it, that would now make the Cook process base class useless. It wouldn't have a use anymore. In such a case, I should have just had a, and my iCookable should have had all 4 methods on it, or maybe just only the 3 you see here. So I need to code it this way for it to make sense, actually.
Gotcha.
So the answer is yes, it's possible, but in this case, it would not have made sense.
And then the interface, iCookable. For this to really be exceptionally useful, you would need lots of classes to put iCookable on. Right? I said it.
You need at least 2.
At least 2.
That's usually the rule I go with. It's like just conceptually, it's sort of a philosophical question. It never makes sense to have any abstraction in your brain ever if there's only one concretion. That's a bunch of technical terminology, but without 2 classes to implement it, you don't need it because it's enforcing a rule that's already correct in the single one class that exists. Its value only appears when there are 2. In this case, I don't have 2, so my iCookable interface is not useful. I can just say it out loud. It's not useful in this particular case. I could make it useful if I added a different kind of cookable Cook process.
Right. Okay.
In this case, though, it was overkill. But I did still want to show both being used in an example. But in this case, it was not highly valuable. Any questions about inheritance or interfaces?
Is this the last OOP introduction thing we're doing? If so,
I think so.
make them code some.
I think so.
Make them prove that they know it.
We could set up a, you want to do an exercise that's like this? That's cool. I want to make sure there's no other questions, though. Because almost, we'll come up with an exercise, and so you'll be working on it. Last chance for a question. All right, so I don't have a planned exercise, a follow-up here for this particular set of stuff. So we've talked about breakfast. What's something else that we do that we can turn into an exercise? Something else you do in your real life or some other thing that happens? Just throw out anything. Something we're modeling, something a customer might ask us for in some app, anything.
A workout.
A workout? Okay, that's pretty good. A workout has a process to it. That's good. Obviously, there's different kinds of workouts. You could be walking, you could be running. Okay.
Walk around, lift weights.
What's that?
So you can walk, you can run, you can lift weights.
You can walk, you can run, you can lift weights. Lifting weights, that's a good one. gear that you use, right? Yep, I have different gear. Yep, I like that.
Um,
So weights will have gloves.
gloves, right? And weights.
Gloves, sure.
You have to stretch.
You have to stretch. That's a good one. Yeah, you don't want to be pulling anything. Getting any cramps. Swimming's a good one. Swimming could be one. Right, you have to put on a swimsuit maybe, stuff like that. I've been pretty specific in the exercises. I'm thinking here to be just sort of let people do whatever they want.
Yeah, let's make this spec technical and let them implement however they want.
Yeah.
Can you put the oatmeal cook process?
Yeah, oatmeal cook process is on the screen. There you go. Notice it derives from cook process and implements all three of the methods specifically for oatmeal. All right, so let's do that exercise. Let's model some sort of. We'll set you loose. You'll do it yourself, and then we'll reconvene, and I'll put something together, and we'll compare and contrast what we came up with.
What exactly, which concepts do you want them to practice specifically?
You definitely need to use a parent class. It's I'll make interfaces optional. My thought is if you understand parent classes, especially ones that have abstract methods on them, it's pretty much the same as interfaces. So just use at least one parent class and have at least 2 child classes, because then it will actually make sense. Model anything in this sort of like exercise, workout sort of strategy, and just tinker with it. And of course, this is actually the part that I enjoy the most, is walking around helping people. So I'll be wandering up and down. Please ask me questions. I'm not looking over your shoulder to snoop. I'm hoping you'll ask me questions and we can talk about your specific implementation.
I'm gonna put the exercise in Slack.
Yeah. Link GitHub
Yeah.
repository. Oh, do we want to do the Skype thing? Let's see if
Yeah.
Richmond wants
Let's
to do
do that.
Skype.
Let me go back to iCookable for a second.
iCookable.
You wanna put this up in there just so they have a reference.
I will try. Are we switching to Skype?
I don't see any. I asked if anybody had any questions and nobody's responded, so I take that as a no. So we can skip it this time.
Okay.
Maybe after we do throw. But after we do a new concept.